Quickly, let's solve these three questions on the board. Yes. We have here limit as x goes to 0 for this function. What do we do first? We simply go ahead and take the limits. So when we take the limits, taking the limits, what happens? This will give us exponential b times 0 minus 1 all over 0 squared. B times 0 is 0. E power 0 is 1. So I have 1 minus 1, that is 0. 0 squared, 0 in the determinants. So what do we do? We apply L'Hopital's rule. Yeah. So we said, so apply this rule is simply differentiating the function that gave us 0 over 0 individually. So e power bx, first, because it's e, we go for the power. That will give us a new limit, which is now limit as x approaches 0. That will give us b exponential bx minus 0 all over, that will give us 2x. So we'll take the limit again. Taking the limits again, what happens? We have this to be b exponential b into 0. We are putting 0 wherever we are seeing x. B is a real number, a constant, so don't leave it like that. Here's out. All over 2x will give us what? 2. So now, if I simplify this, all I have, sorry, this is x, right? So I have to include the x here also. That is 0. If I simplify this, that will be b times 0, 0. Exponential 0, 1. 1 times b is what? B. Yes. All this place, all here is giving us 1 because b times 0 is 0. Exponential 0 is 1. 1 times b, b. So I have here b over 2 times 0, 0. We have b over 0, a constant over 0. So what do we do? Our answer will be infinity. Please note, when you have a number over 0, you don't apply L'Hopital's rule. Yes, you don't. The only time you apply L'Hopital is when you have 0 over 0 or infinity over infinity. In our next class, I will take my time and explain to you what we mean by infinity. But note that any limit in which the answer is infinity, that limit, you can say it does not exist. So in case you don't see this one, the option provided for you, DNE will be there. A limit that exists will have a real finite value. So infinity is just divergent, does not have a particular finite value. So the limit here does not exist. Let's solve question 2. Before we take the limits, we have to observe something. The function here contains a square root. Before you take the limits, observe if it's possible to get the left hand limit and also the right hand limit of your inputs. Check our first video on limits. For this one, yes, it is possible to obtain the limit as s goes to 1 from the right, and also limit as s goes to 1 from the left. These two things are possible to obtain from this function. They are possible. Because if I put numbers close to 1 and bigger than 1, I'll have 1.01, and the root of that is possible. Numbers less than 1, 0.999, the root is possible. But look at this. Limit as s goes to 1 of root s minus 1. This one, the only thing possible is the right hand limit. Possible. For this one, I can't obtain the left hand limit. Why? Numbers close to 1 and less than 1, for instance, is 0.999. And 0.999 minus 1 will give us a negative value. And the root of something negative, the root of a negative number does not exist. So in a case whereby we can't obtain the left hand limit or the right hand limit in a function, the limit of that function does not exist. I know that in your head you are thinking that the answer here will give you 0. 1 minus 1, 0, with 0, 0. No. The answer here for this limit is D and E, does not exist, because we can't find the left hand limit of this function. So it is proper that you observe your square root if the left hand limit and right hand limit of your input will exist before embarking on direct substitution, the concept of limit. Here also, we can obtain the left hand limit and the right hand limit of our input too. Hence, we can proceed. Yes, the concept of limit is not about just taking your limit. It's about knowing when the limit exists and not otherwise. So quickly, let's solve this since our input will exist on both hands. Taking the limits, we'll have this to be s becomes 1 everywhere. That will be 1 squared minus root 1 all over 1 minus 1. And this is 1 squared, 1, root 1, 1, 0, 0 in determinates. So what do? We apply L'Hopital's rule. Applying L'Hopital's rule. What will happen? We differentiate this function individually. Yes, you can run here, here, and here. But here will give you a problem if you don't know the basic idea of differentiation for square roots. Let me show you how square root works. If I give you something like this now and say differentiate, if I give you a square root and say differentiate this thing, if y is this, find the y the s. If I give you a square root to differentiate, it's simple. How do you achieve it without solving? Without solving anything, to run this thing down, you simply draw a fraction. Take this t you're going to differentiate. Take it and put it under 2x power 5 plus 3x plus 7. What you want to differentiate, keep it under. Yes, that's it. Now differentiate the content of your square root. Everything inside the radical symbol, differentiate it. 2x power 5 will give us 10x power 4. Yeah. 3x will give us 3. 7 will give us 0. We are almost done. Because the square root, you have to attach 2 under here. That's it. Anytime they give you square root function to differentiate, you simply differentiate the content of the square root, keep your answers on top, and put 2 here. Don't ask me why. Always put 2 there, provided a square root. So if I have to differentiate this, if I apply the L'Hopital's rule, this becomes limit as x goes to 1. Here will give us 2x. Here will give us minus. Differentiate inside, I'll have 1 over root x. Are we done? No. Put 2 at the side. That's it. That's it. All over x minus 1 will give us x will give us 1 minus 0. Yeah. So we'll take our limit again. Taking our limit again. What happens? This will now be 2 into 1. X becomes 1. 2 into 1 minus 1 over 2 into root 1. Yes. All over 1 means the same thing. Anything over 1 is that same thing. So there's no need of writing over 1. So this will be 2 times 1, 2. Minus root 1 is still 1. 2 times 1, 2. That's half. 2 minus half is 1.5, which is equal to 3 over 2. That's it. Of solved question 2. That's our limit. Question 3 is similar. It's similar. We've confirmed that yes, we can actually find our left and right hand limit as x goes to 2 from this function. You can also apply the method of rationalization that wants you to perfect your skill on L'Hopital, basic differentiations. In calculus, you must be able to perform this basic differentiation. Sam, are you following? All right. For question 3, let's take the limits. Taking the limit, we have 4 minus 2 squared all over 3 minus root 2 squared plus 5. And this is 2 squared is 4. 4 minus 4, 0 all over. 2 squared 4. 4 plus 5, 9. Root 9 is 3. All here is 3. 3 minus 3, 0. Indeterminate. So what do we do? We apply. Applying L'Hopital's rule. To apply, it means differentiate the function that gives us 0 over 0 individually. That will be limit as x goes to 2, yes, 4 will give us 0 minus x squared differentiate 2x all over 3 will give us 0 because once you don't have x, it will become what? 0 minus. How do we differentiate for square root? Remind me. We said that if we have square roots, we have to draw a line of fraction. Yes. This whole thing here, we bring it down, right? Yes. X squared plus 5. That will differentiate everything down here. That will be 2x. Yes. Are we done? No. We put 2 under. We are done with this. Next, we simplify and take our limits. Yeah. I hope you can. Yes. If this will confuse you, just take your limit directly. So, I can, this term, this and this are together. So I can still say that this is limit as x goes to 2 of negative 2x over 1 times. You know what happens when we change division to multiplication? What happens? We have to invert the division under. That will be 2 roots. Please negative still here. Negative 2 root x squared plus 5 all over 2x. Yeah, it's clear like this. 2x can remove 2x. Negative can remove negative. We are left with 2 root x squared plus 5. So taking the limit again. That will be 2 roots. What's our x? Our x is 2. 2 squared plus 5. And this is equal to 2 into, here will give us root 9, because 2 squared plus 5 is 9. Root 9 is 3. So that will be 2 into 3, which is 6. We have solved it. That's it. Being successful in solving limits requires basic idea of differentiation. If I give you something like this now, let's say limits as x goes to 0 of sine 2x over x. It's very simple. Once this thing gives you 0 over 0, your success here depends on your ability to differentiate this. So for sine 2x, what do? Differentiate 2x first to have 2. We now have sine to give us cos. 2 cos 2x all over 1. Taking the limits again, you now obtain that 2 times 0 is 0. Cos 0 is 1. 2 times 1, 2. 2 over 1, 2. Your success on solving limits depends on your basic knowledge of differentiation. So quickly, we'll look into limits that tend to infinity in our next video.